Welcome back to the conclusion in our series on conceptual modeling. In this chapter, we presented the modeling concept of a high-level conceptual data model, the entity relationship model. We started by discussing the role that a high-level data model plays in database design processes, and then we presented a sample set of database requirements for the company database, which is one of the examples that is used throughout our textbook. We defined the basic ER model concepts of entities and their attributes. Then we presented null values and presented the different types of attributes which can be nested arbitrarily to produce complex attributes. We noted alternatively, we discussed weak entity types and the related concepts of owner entity types, identifying relationship types, and partial key attributes. Entity relationship schemas can be represented diagrammatically as ER diagrams. We showed how to design an ER schema for the company database by first defining the entity types and their attributes, and then refining the design to include relationship types. We displayed the ER diagram for the company database schema. We discussed some of the basic concepts of EML class diagrams and how they relate to ER modeling concepts. The ER modeling concepts we have presented thus far, entity types, relationship types, attributes, keys, and structural constraints, can model many different database applications. However, more complex applications such as engineering design, medical information systems, telecommunications, require additional concepts if we want to model them with greater accuracy. Whether you're building a house, designing a new airplane, constructing a building, developing a computer program, or developing a database, one must always have a plan in advance. Otherwise, it's a hit and miss proposition which will create never-ending problems in the development of the project. The ER diagram and conceptual modeling is that plan when it comes to developing a database. It is an approach that needs to be used by anyone who is serious about working in this area and developing a database. I know that many of us have been working recently in SQL, learning how to create tables and attributes and so forth in that programming language. Nevertheless, in the real world, when it's time to develop databases that really will mean something, that organizations will depend upon, it is crucial to use whatever approach you can use to developing a detailed, accurate plan for what the result of the project should be. So there you go. That completes this series on conceptual modeling. In the next series, we're going to discuss normalization in relational databases. Come back and join us for that.